Section 1.2 will focus on the real number system and what are the names of the different subsets of that real number system. How can we define different types of numbers? How do we know what types of numbers we're talking about? The second part of this section is going to talk about the properties of real numbers. What properties do we know are always true that allow us to solve different types of problems? We're going to look at these two things. It's a pretty vocabulary-heavy section, so this might be a good situation to make some flashcards that could help you with these kinds of definitions for your test and quiz. We'll be spending a lot of time in class practicing with these different vocabulary words, but it may also be helpful to create some kind of study device for yourself. And so the first type of numbers in the real number system are just what we call the real numbers. And this is the largest group of numbers that we're going to be working with. This includes the set of all rational, and I'll tell you what that means in just a minute, and irrational numbers. So up to this point in your math career, the real number system includes any number that you're really familiar with. It would include pi, it would include the square root of 2, it would include 0, -7, 14.5, and all of these other numbers that you can really think of. So rational and irrational numbers for now, and we'll get into things that aren't real later on in the year, but for now, real numbers really include everything that you can think of. Rational numbers specifically are any number that can be expressed as a ratio of integers. So a ratio is a fraction, right? And so whenever I say the word ratio, you should really just think that what Ms. Coggs was talking about is a fraction. This is just a fancy math vocabulary word for fraction. And so as long as I can write that number as a fraction of integers, then it's technically a rational number. Rational and ratio, those things go together, right? The ratio is actually hidden in the word. And so examples would be any fraction you can think of. So -75 over 301, right? Or in this case, that's a fraction of integers, but anything that could be written as a fraction of integers. So if I had the number 3.00001, I could technically turn that into a fraction. And as long as I can do that, it would count. In fact, repeating decimals, so the decimal of 0.3 repeating we know is equal to 1/3. That's a fraction of integers, so that's technically a rational number. One way to tell that something's going to be able to be written as a ratio of integers, if it's written as a decimal, is if it terminates, which this did. This had a final ending number, or if it repeats. So this had a repeating bar over it, so this would also be something that can eventually be written as a ratio of integers. Irrational numbers is a number that in decimal form neither terminates nor repeats. So this is like the opposite of our rational numbers. So ir is a prefix that means not. So anything that is not rational is irrational. And so the examples here might be things like pi. We know after all of our work in geometry that pi is a decimal that continues on forever without terminating or repeating. I could write something like 1.010010001 ... So I'm going to put the little ellipsis after it. This shows that it continues on forever, but there's nothing that I could write a repeating bar over. There's certainly a pattern, but I can't demonstrate what's repeating. Other things that are irrational that you may not be as familiar with are square roots that don't work out evenly. So something like the square root of 2. If I were to put the square root of 2 in my calculator, it doesn't work out evenly, and so that number technically is irrational. So another example might be the square root of 15. It doesn't work out evenly. So anything for our purposes that is not a rational number, that can't be written as a decimal or as a ratio of integers, is an irrational number. Integers are whole numbers and their opposites.
Teachers, this is just a